A therapeutic fasting intervention may be an appropriate component for a personalized treatment strategy and may improve health across a range of areas, from mental and cognitive performance to cardiometabolic health to the effectiveness of cancer treatments. The potential benefits of fasting likely work through multiple pathways, such as reducing oxidative stress, enhancing mitochondrial health, and triggering autophagy. Now, even more studies indicate that fasting positively impacts the gut microbiome.
Some of the more recent studies actually show that those people who do early time-restricted feeding, that is, eating in the morning time, actually have greater changes in the composition of their gut microbiome than do people who use a later period of time-restricted eating. And so that to me says there may be something to really be able to create a foundational difference in following the sun.
In this episode of Pathways to Wellbeing, IFM educator and functional medicine expert Dr. Patrick Hanaway joins us to discuss the fasting gut connection and to explore how benefits to the gut microbiome may translate into improved patient outcomes. It's always a pleasure to chat with you. Welcome to the show, Dr. Hanaway.
Thank you so much, Kalia. Patrick, please.
Well, Patrick, we've been listening to you lecture about fasting for years. It's always fun to hear you talk about this because you have a clear passion for the subject. And we know that you're an educator on our GI module. So when all this research started to pour out about the benefit of fasting on the gut microbiome, did you feel like the stars were aligning and your clinical loves were coming together?
Well, it just seemed like the most natural connection because so much, as we know, happens is mediated through the effects of the gut microbiome. So it's not surprising at all that the circadian rhythm that we see with intermittent fasting would also be mediated, at least in some way, through the gut microbiome. And, we'll talk about how that actually happens and what gets affected. But I have been a champion of fasting. It was first introduced to me by my son about 10 years ago. He was an athlete in high school at the time, and he was learning about it. And I began to dive into the literature on it, and it's like, oh, it's actually really quite effective. And of course, it makes sense when we look at what people have done, over cultures, over long periods of time. That fasting and having periods of less food are going to be a natural part of being human. So maybe we need to relook at that, and we are, and the data is pretty impressive.
It's certainly exciting to see more and more literature supporting the use of fasting as part of a therapeutic treatment plan. And research is showing that therapeutic fasting might benefit multiple body systems. So in functional medicine, we would translate that to the functional medicine matrix. In general, will you tell us what are some of the areas that have shown positive associations with fasting treatments? How is the matrix affected?
Well, first I'll talk about it more from a disease state, and then I'll talk about it from the matrix. And that is, I think first and foremost, the effect on cardiometabolic syndrome and insulin resistance and weight loss and dealing with obesity. Certainly that's where it's gained its first major effects. And through those mechanisms, we see changes altering CNS function. But in addition to those things, we can see the effect of fasting on the immune system and decreasing inflammatory biomarkers. We can see fasting's effect on energy production pathways and the mitochondria. Probably some of the most important effects are mediated through the mitochondria and the whole energy production system, which of course is going to affect, things not only like fatigue, but brain fog and central nervous system issues, because the brain is the largest user of energy in the body. So we also can see that a normal diurnal variation is necessary to be able to deal with environmental sensing and detoxification as well. I haven't seen so much on hormonal aspects that have got on, but certainly on the cardiometabolic aspects, there are critical factors. And of course, within the structural zone, we do see changes in the structure of the gut microbiome itself. from fasting. So in a lot of different areas, and I do hope that we can have a chance to talk about some of those aspects around fasting and cancer treatment. That's also a passion for me, something that is up close and personal.
Absolutely. Well, we've established that the benefits of fasting reach across several body systems. And I'm curious to know, what are some of the high level known mechanisms that help to explain these positive associations that may be seen between fasting and health in all of these different clinical imbalance areas?
I think one of the areas first is when we begin to look at, well, what happens with fasting in and of itself. And we know that that decreased caloric intake by 30% will affect longevity, but we know that's also not possible to be able to do. And so we have fasting mechanisms of intermittent fasting or time-restricted eating, that has come forward that is probably very similar to what our ancestors for hundreds of thousands of years experienced. They didn't have food all the time. And so they moved in a way where there were circadian rhythms that developed. And those circadian rhythms actually within the gut, they get mediated through or kind of maybe I could say governed by or conducted by a part of the brain called the suprachiasmatic nucleus, SCN. And that acts to be able to set the diurnal rhythm, the circadian rhythm in the gut, which is then when food is introduced. And this is a great word that I've learned recently, but food acts as the Zeitgeber. The Zeitgeber, what that means is that's a rhythmically occurring natural phenomena that sets the regulation of the circadian rhythm. And so food is actually one of the things that sets forth the circadian rhythm that goes on. And in that process, we see changes in the gut microbiome that occur. We can talk more about that, both in terms of the structural makeup and the functions that are going on. And so we do see changes, as I said earlier, in insulin sensitivity and insulin resistance. Of course, that's going to have an effect on cardiometabolic syndrome, but all the aspects that we see insulin resistance having issues with, as we've talked about within our cardiometabolic module for a long period of time, be they related to weight and obesity, cardiovascular disease, heart disease, dementia, other forms of mood disorders, all of which, and cancers, all of which can be regulated through insulin resistance. And so that interface of what's going on is a key piece that's occurring.
It's really interesting how you're starting to take circadian patterns beyond just light and darkness cues and introducing now food is also one piece of information that's feeding into those patterns. And I think that's fairly new to many people.
It's true. And what's interesting is that, the light and darkness cues that we think about within circadian rhythms, what we find is that in the dark period is actually when the functional energy metabolism pathways are maximized. It's when it's down, that's when the body gets to sort through what's going on metabolically. And so having a break point from any food during that process to be able to deal with apoptosis and mitochondrial death and regulation of the system makes perfect sense, because it's during the light, that we have to deal with those issues of, detoxification and motility and sensing of the environment. And so it just makes sense that, well, how about if we have a period where we're not introducing food into the system during that time, no late night popcorn, or munchies or something like that's going to disrupt that process, not unlike what we see with sleep patterns, where the deep sleep that happens early in the sleep pattern is crucial, and so we need, and that's so important, for the brain and for our mental function with sleep to have that downtime. So too, it's necessary to have that with food. And, it makes perfect sense when you look at how humans have evolved and what are food stores, what's been available, and how we've moved with that.
Right. Here in the Pacific Northwest, where I am, in the wintertime, even in the fall, it might get dark at 4:30, 5 p.m. And I've had patients ask me, should I try to stop eating right around the time that it gets dark? And I'm just so curious to hear what you think about that.
It's a really interesting question, because I think that when we look at climes that are farther north, and as you may recall, I lived on the Bering Sea in Alaska for a couple of years, and we'd have 2 hours of daylight in the winter and 2 hours of darkness in the summer. And so I think that it's not quite like that, because I do see the data that we have on time restricted eating, that's been looked at like through the year, seeing changes in immune function in one wonderful study that was done. I think it should be applied throughout the year. Now, one of the interesting questions that's been raised, and I've seen different answers around it over time, is does it make a difference if you do a time restricted eating where you only eat in, let's say, in the morning time from 8 a.m. until 4 p.m., or only in the evening time or in the PM time, say from noon to 8 p.m. or something like that? And the data actually hasn't shown significant differences metabolically, but some of the more recent studies actually show that those people who do early time-restricted feeding, that is, eating in the morning time, actually have greater changes in the composition of their gut microbiome than do people who use a later period of time restricted eating. And so that to me says there may be something to really be able to create a foundational difference in following the sun. And again, with the light and dark cycles that are involved with retinoic acid receptors and things like that, as well as light receptors, it makes sense. But we haven't seen data. And in fact, the papers that look at what they say ETRE, early time restricted eating, haven't actually related that to what the time of the year was or where the sun was. And that's an interesting question to ask. I think if the patient came to me and said that, I would say, if you're going to do time restricted eating, it makes sense to follow the sun.
Yeah, that just makes sense. That makes sense to me too, especially all of our traditional Chinese medicine and Ayurvedic colleagues who have been telling us to follow those circadian patterns. That just makes a lot of intuitive sense. Now, Patrick, I feel like we have to address autophagy in a conversation about fasting. Maybe that term is new to some listeners. Will you just give us a brief overview of what the term autophagy means?
Well, when we're talking about autophagy, we're really the simple way I think about it is house cleaning. And that is that we have cells that are dying, but they're hanging on. And there needs to be a cleaning out of those cells that are not able to perform at their highest level of function anymore. So we see what happens within time restricted eating or a fasting mimicking diet. There's really great data, from Walter Longo's group at USC around a fasting mimicking diet, that is restricting in calories and restricting in particular amino acids, that helps to promote autophagy, that helps to promote that cleaning to be able to occur. And so we see that with time restricted eating. We see that actually more so with longer fasts, like with what's it called, a Buchinger fast, where it's 5 days of fasting that's occurring, or even with alternate day fasting. We can see higher amounts of pushing that cleansing process of autophagy to be able to occur. Don't want to spend a lot of time going into all the pathways around that. It's very fascinating in the way that it works. We also see the aspects of I've already mentioned, fasting before chemotherapy, which gives a differential stress response, and that actually helps those cells of ours that are susceptible to go through autophagy or to move into a quiescent state. And those cancer cells that are really in need of glucose and support in order to be able to continue to grow, move into a state that makes it much more susceptible. And so I find these things to be, fascinating aspects of the same conversation about looking at the role of food and fasting and autophagy.
Very approachable explanation to a somewhat complicated subject. I had a patient once who was doing some fasting, and she was telling me she was combining this with some visualization exercises in which she pictured little scrubbers inside her cells doing their house cleaning. So maybe that's becoming more common practice. We're doing our fasting and our mindfulness exercises at the same time.
Well, I think then, in that setting, it's an interesting idea. But the scrubbing should be done, kind of when you're 12 hours into it, not just right away after you finish dinner at 5 p.m. and are going to eat next again at 8 a.m. the following morning or 9 a.m. the following morning. And it also begs a question of, well, what is it? I think that the data shows that, 16 hours of fasting is significantly better than 12 hours. Of have patients start at 12 hours and then move to 14 and then move to 16, and for some who are more interested in doing that, I'll move them to a 5-2 fasting cycle with 5 days of eating and 2 days off eating. But that 2 days off of eating ends up really being more like a 32 to 36 hour fast, which actually optimizes the autophagy.
Right. Well, I would love to direct us towards all of these benefits in the gut, because that's what we're really focused on today. And recently, there's been studies that have explored this benefit of fasting on the gut microbiome specifically. I wanted to talk about these various benefits, and starting with one that I think in functional medicine, we love to talk about: inflammation. We're inflammologists. Can we impact intestinal inflammation with therapeutic fasting?
Well, there have been some studies looking at inflammatory bowel disease that do show that using a time-restricted eating pattern will decrease the overall production, or decrease the degree of severity of inflammatory bowel disease. It doesn't get rid of it, but we do see a decline in the inflammatory biomarkers. I've not seen one that specifically looks at my favorite inflammatory biomarker in the gut called calprotectin, but we have seen other measures that have been done, and then we also see studies that have looked, I mentioned one study that's actually talked about in this insight from the Institute for Functional Medicine on fasting and immune health, that talks about decreases in inflammatory cytokines throughout in patients who are using a time-restricted eating pattern of 8 hours over a 1-year duration of time. And so in comparison to their before levels of cytokines and to control, we find that there's improvement. And we recognize that, as you say, as inflammologists, that much of what's happening in that low-grade inflammation in the gut that drives insulin resistance, that can drive systemic inflammation, is actually the driving of initial cytokine production occurs through the pathways in the gut, not only in diseases like inflammatory bowel disease, but across many other states of low-grade inflammation. And of course, we see this in our, autoimmune patients. We see this in many patients where there's a low-grade inflammation that's happening. And in my sense, over a long period of time, is that's being driven by alterations in the ecosystem of the gut microbiome. And we do see changes in the ecosystem of the gut microbiome happening from time-restricted eating. Those can be changes that will lead to increases in ruminococcus and butyrate producers. They can be changes in mRNA transcription factors that relate to, sirtuin-1 that's associated with longevity, or to, foxhead proteins that are involved in inflammatory processes, or also in in several other transcription factors, one called clock and one called BMAL1, that have an effect on inflammation itself. So we are seeing that time-restricted eating will change transcription factors. It will change the overall composition and diversity of the gut microbiome, all of which are factors that help to decrease the overall inflammatory process. And then again, like I said, and we see that manifesting in a study on inflammatory bowel disease, and we see that manifesting in a study looking overall at cytokine production.
Patrick, do you have a sense of the timeline here? Let's say someone begins doing time-restricted eating. How long until we might see a shift in their gut microbiome?
Well, it's interesting, when we, I've been talking about the gut microbiome for a long time, right? So probably now almost 30 years. And what we thought early on was that there weren't significant changes in the gut microbiome when we changed that dietary patterns. Now, what we found is, well, yeah, that's true if you keep eating the same thing. Now, when you start to change both the types of food and the frequency of food that you're eating, we begin to see changes in the gut microbiome really within 24 hours, but certainly within 3 days. Those become more, let's call more institutionalized within 2 to 4 weeks period of time, where there's the new mix that's there. But one other thing to note is that when you stop intermittent fasting, the changes go away. So it's there as a function of that process, of that resetting of the circadian rhythm and the changes that then occur, where there's a modulation of the abundance of particular bacteria. There's a change in the diversity. The diversity actually happens first, and then the abundance happens over time.
I imagine with this shifting in the microbial composition that we also might notice some changes to metabolites like short-chain fatty acids. Is that something you're seeing in the literature?
So again, the literature is very early at this point in time. And so there are some studies that have been done, some of which do show increases, as I said, in things like ruminococcus, that's a butyrate producer, that do show improvements or increases in overall butyrate production that's going on. But there's some mitigating factors. What was your diet before you started? What gender are you? What type of eating pattern are you actually doing? It is alternate day feeding. Is it a time restricted eating of 12, 14, 16 hours? Is it a 5-2 process? Is it a buking, or is it Ramadan? There's lots of different studies that have been done to look at these, and they get some different results. And one of the interesting things to me is they get different results, based upon not only gender, but also upon body type. So the effect on people who are overweight and obese is different than people who are not overweight in terms of the metabolite changes that we see going on. We do see some changes that relate to the short chain fatty acids, to butyrate itself. We see some other changes. What I think is going on, Kalia, is in relationship to the postbiotic effect. It's not just what's happening with the microbiome. It's happening with the metabolites that are produced by the microbiome that act as antioxidants. And so they're stimulating antioxidant and enzymes, whether it's glutathione S transferase or superoxide dismutase. And we see some interesting data in C. elegans in a longevity model that actually shows that a postbiotic milieu or mixture can actually shift the overall oxidative stress that's going on in the gut through shifting not only the products that are there, but changing the activation of antioxidant enzyme systems that are present. And so I think that's what we're going to begin to see. But now when we talk about this, recall that, we may say, short chain fatty acids, of which there are 3 primary ones, butyrate, acetate, and propionate. There are putrefactive short chain fatty acids that come from insufficient digestion of proteins that are more fermentation byproducts. but so even naming just those 6 various short chain amino acids are 6 of more than 1,000 different metabolites that are produced by the gut microbiome. And so I think we need to actually be able to look at a systems approach to see what's going on. And that's what I like to look at changes in insulin resistance patterning. So on a clinical basis, when I'm working with patients, I'm looking at what's happening with your fasting insulin. I'm looking at what's happening with your hemoglobin A1C, what's happening using a continuous glucose monitor to be able to see changes of how your glucose metabolism is occurring as you're working with tools like a fasting mimicking diet and an intermittent fasting or time restricted feeding pattern. Those are the things I think are the ways that I can see clinically what's happening. Also look at something like an NMR insulin resistance score that helps me to see what's actually happening with insulin resistance. So those are the tools that I'm using clinically to be able to help determine, are we moving in the right direction, and is it effective? One other side note that I'm curious about, and I haven't seen enough data on yet, and maybe you know something about this, is that, we see that with other kinds of dietary patterns, like a ketogenic pattern, and I'll often combine a ketogenic diet with intermittent fasting, for my patients, but I don't see as good of an effect in women as I do in men. I don't know why that is. I've seen it described by others. I've talked with colleagues who've noted a similar thing. I don't understand why that is. Do you have any thoughts on that?
No, but that's fascinating. Do you mean you don't see as the metabolic changes, for example?
Yeah, right. As significant of metabolic changes, or even that kind of reset, I don't see it to the same degree in women as I do in men.
Fascinating. If any researchers are out there listening, we're going to need you to conduct this research so we can do a follow-up episode on that.
Exactly.
But Patrick, you've mentioned the systemic effects. So insulin resistance, you've talked about the exacerbation of autoimmune disease, you've talked about. And I think in my mind, I often relate these back to intestinal permeability. And so that leads us into this conversation about gut endotoxins. Do we see an effect on endotoxins with fasting? And then we can talk about how that influences intestinal permeability.
We do. And now this is more benchtop research and animal and mouse research, where they've actually been looking at LPS, lipopolysaccharides that are generated from gram-negative bacteria, which we know will have an effect on increasing zonulin levels and increasing, paracellular, intracellular permeability that's going on. And that we do see that the production of LPS is decreased when there is time restricted eating patterns and intermittent fasting that goes on. And so again, I don't know if that relates simply to the presence of gram-negative bacteria, or if it's related to some other kind of quorum sensing phenomena, because we're not seeing, huge shifts in the overall distributions. Some of the studies will say at the phylum level, we have an increase in Bacteroidetes relative to Firmicutes, but we're not seeing huge shifts in the overall distribution of what's going on that would necessitate, or that would correlate with a huge drop in lipopolysaccharides or a huge drop in gram-negative bacteria. So we can describe that. We see that in the literature. Yes, there is a decrease in LPS, and that means there's going to be a decrease in intestinal permeability that occurs. And certainly there's a benefit that will occur across those disease states, specifically, like you said, the autoimmune conditions where we're particularly worried about intestinal permeability. But whether that's manifesting itself through changes in the composition of the microbiome, again, or due to the metabolomic production of what's going on by the bacteria that are there as it moves into a different circadian pattern that's going on. I don't know if I'm making sense with this. I want to just try to state it simply. It may have more to do with what the the metabolic functioning is that's going on, that's causing changes in the LPS, than it is the actual composition of the gut microbiome. And this leads me to an important point that I wanted to focus on. And that is that while, we can look at research that says the new family called Cristaceae and the genus of Cristancella and the species of Cristancella minuta, have been associated with centenarians. And there's one study that says, oh, we see an increase in Cristancella. But I think that we're making mistakes when we think that there's going to be one keystone species that we're going to put in and it's going to change everything that's going on in the gut. I don't think that's the way in which we want to approach this. We want to approach this through, whole food dietary approaches with reasonable amounts of food at good timing, using time-restricted eating and intermittent fasting as a means of being able to reset the circadian rhythm of light and dark that our bodies have been using for the past, 500,000 years. So how do we do that rather than thinking we're going to take an Akkermansia or a Cristancella and drop it in and it's going to make a big difference? We do use probiotics therapeutically, but I'm much more focused on the prebiotics and the foods of helping to bring balance back to the system and having those foods be at the right time.
Very well said. Lifestyle factors, nutrition, that's what we're really focusing on, those foundational pillars of health.
Yeah.
I'm going to make a connection here, another matrix connection, because we've been talking about the gut and we just talked about endotoxin. And in the research, we see this hypothesis about an endotoxin neurodegeneration connection. So now we're kind of linking like the assimilation node and the energy node together. Are you seeing this in the literature? Is there a gut-brain axis response to fasting?
Absolutely. And, we've been spending more time talking about this gut-brain microbiome axis going on because we're finding, again, I believe it's because of the metabolites, so we can look at the short-chain fatty acids, we can look at neurotransmitters, we can look at, inflammatory cytokines and what their effect is on the brain, so that information goes along with the afferent portion, the part of the vagus nerve that's going back into the brain, and looking at the anterior insular nucleus that acts as an aggregating factor that then brings all of those pieces together. And we also see, kind of parallel to that, what's happening with echoes of what occurs in intestinal permeability is mirrored by what's happening with permeability of the blood-brain barrier. And so we see two different phenomena that are going on. And so the LPS-mediated neurodegeneration that you talked about may be manifesting itself primarily through alterations in the blood-brain barrier that lead to glial cell activation and inflammatory processes that are occurring and subsequent neurodegeneration. But we also find that there are, as I said, metabolic patterns that go on. So if we were to take something like Parkinson's disease, it's like, oh, well, that happens in the setting of constipation. And we see shifts that are going on in the overall distribution of the gut metabolites that are occurring, that are having an effect on the anterior insular nucleus that then has an effect on the basal ganglia and the ability of movement, or the effect on movement disorders. So there's two different pieces that are going on that I see. I'm sure there are more, but we know, and we can even find through, to just take a chapter from what's going on with COVID and long COVID. We see alterations in tryptophan pathways and chynurenic acid pathways that are stimulating inflammatory changes and degenerative changes in the brain. And so we know that the metabolites have an effect on neurodegeneration, and we know that alterations in the blood-brain barrier that parallel what's happening in the gut lining will have an effect on neurodegenerative processes. So we're beginning to see both of those emerging in the literature. And I don't I don't separate them from each other because they're all mediated through what's happening with the gut microbiome.
Well, I'll layer on another piece to this that you might say, this is all connected. It's really all the same thing. And that's the immune system. You've touched on how our gut health can impact our immune system. But let's link that to fasting. Do we see impacts to our immune health when we start a therapeutic fasting plan?
Yeah, I've mentioned that, a couple times already in relationship to a really excellent study that was done that looked at people over a year period of time and could show changes in inflammatory cytokines, decreases in inflammatory cytokines. And part of the way in which I think that it's also important in the process that we see is that this interrelationship between the gut microbiome and the immune system and the mitochondria. And they're actually working in concert with each other as part of the metabolic pathways that are occurring. And so we need to have a balance between all three of those that are going on. That, to me, forms the basis of health, is working on the gut microbiome, supporting the immune system using foods that are anti-inflammatory in nature, and that helps to balance the energy production pathways, as well as the overall electron transport chain within the mitochondria to be able to optimize its efficiency for energy production that goes on. So I like to think of all three of those together. But to come back to your question specifically, there's no doubt that time-restricted eating and intermittent fasting will have an effect on the immune system, and some of that may be mediated through that apoptosis that we spoke about earlier.
There are so many clinical applications for fasting, and you mentioned earlier that you might be willing to share a little bit about this connection between fasting and the gut microbiome changes and benefits to cancer treatment. So I thought we could spend a few minutes, and I would love to hear your thoughts on this topic.
Well, as you know, this is a personal topic for me. So if I have some emotions around it, it's related to that. I began really looking at intermittent fasting and fasting mimicking diet and relating that to other cultures, and working with insulin resistance about 9 years ago. And in that time frame, I found it to be really potent. And I was aware that much of the work that Dr. Walter Longo at USC had done was actually started with trying to do a fasting before chemo as a way of being able to optimize a differential stress response. That is, how do we make the cancer cells more susceptible and the healthy cells less susceptible to chemotherapy? So that was the research that he had done, and then move that into more anti-aging, apoptosis, insulin resistance, kind of promoting fasting mimicking diets in a broader context. But the genesis of it was from his work on cancer and fasting before chemo. And he showed initial data in 2009 through his lab of the benefits of it. And they carried that forward. And so it was in the back of my head when I got cancer, stage 4 cancer of the neck, in the area epiglottic fold with lymph nodes on both sides. And I was doing a ketogenic diet at that point in time, which I later found helps to expand the therapeutic range of the radiation therapy. But what I also chose to do was as I went into the literature, I'm like, well, what does it exactly say? How long do you need to fast? And they did fasting that looked at, 24, 48, 72 hours. A lot of the data is on breast cancer, and it's been published in, Nature Communications, and they've been able to demonstrate a increased effectiveness and a decreased toxicity from the chemotherapy. So, I said, okay, well, it looks like it's about 48 hours is the time frame. You don't get a big bump out between 48 and 72 hours, but having weekly chemotherapy and choosing to not eat or 400 calories or less for 2 days a week. And my oncologist wasn't very happy about that idea. He's like, I'm worried about you losing weight and you're going to not eat for 2 days. But what I found was I was able to move through the chemotherapy, without, because I was on a ketogenic diet, without steroids, without having the need for antiemetics like Zofran, and did really well. And they were like, you're acting differently than the other patients who get this kind of treatment. And I didn't lose significant weight during that period of time. My weight stayed pretty stable. I think I lost 5 pounds through the 8 weeks of treatment. So I've worked with cancer patients around this, and I find that when they work with fasting before chemo, it's much easier to do when there's a Q2 or Q3 week chemo process that's going on. It's harder to do when the chemotherapy is over a 4-day duration period of time. But for those who are receiving chemotherapy, and again, to be clear, the data has been demonstrated of its efficacy, increased efficacy and decreased toxicity in breast cancer. That's where the studies have been done, and there are several studies, and they're well done and well conducted. And so if you're looking to do this, but I do talk with my patients who have cancer about the importance of doing this. Not all of them are able to do it, and the data in the studies that have been done is 400 calories per day, and I usually focus on a bone broth as a means of being able to do that. In terms of that overall caloric intake during that period of time. But it is important and meaningful to me. And I think it made a big difference in my ability to move through, chemotherapy is toxic by nature. It's meant to be. How do we focus that toxicity differentially on the cancer cells and not on the beneficial cells of our body?
Well, Patrick, your experience and your story is so powerful and so compelling. And those of us who have heard you speak about your entire journey, I mean, it is really heartfelt. And I think we take away so many incredible insights from your experience. Do you think that the application of fasting and the ketogenic diet will become more standard in oncology moving forward? I mean, when are we going to see this take foot?
There's two different aspects of what you're speaking to there. So the first is around intermittent fasting or fasting before chemo. And I think that we have a lot of great opportunity to be able to do that. I think that is something that, interestingly, and if you read the literature, the oncologists will say, well, that's ridiculous. No one will ever do that. But do you ask the patients, and they do it, and so the number of dropouts in the studies that have been done are actually quite small, even though it was thought that no one would want to do it. So I think that we're learning how to begin to be able to do that. And I don't think we know which cancers it is best for and which ones it may not make a big difference for. I'm not talking about this in relationship to immunotherapy. I'm only talking about it in relationship to chemotherapy. And then the other part of your question, which was about a ketogenic approach or, a cellular metabolic approach, as we see, a number of our colleagues talk about. But that is for specific cancers that are more insulin sensitive. Not every cancer is going to be affected the same way as, glioblastoma multiforme, or the radiation sensitive cancers like mine and ENT or rectal cancer. We see breast cancer and colorectal cancer and pancreatic cancer all being in a range that they may be more susceptible for a ketogenic diet, and certainly for a low carb diet. But other cancers, it's not been demonstrated for in the same way. So it's not a global one size fits all. Prostate cancer is another one where, like, early prostate cancer is much more insulin sensitive than our later prostate cancers. So we have to really personalize the treatments that we use. And that's part of what we're doing within our functional medicine approach. Is we're personalizing and individualizing it so that we can give the person the best opportunity for their milieu to be optimized. And I think time-restricted eating is one great way to do that, is to reset the circadian rhythms that go on. And for me, it's a lifestyle at this point in time, so probably, 320 or 330 days out of the year, that's what I'm doing. There's times where I may, go to the beach or have a brunch with my mother, where I'm like, okay, I'm going to do this. I'm not rigid about it, but that is mostly what I do, is a form of time-restricted eating of 16 to 18 hours without food during the day.
Well, you have shared so many groups that could benefit from fasting. We've talked about autoimmune disease, inflammatory conditions, metabolic disorders, patients going through cancer treatment. I mean, is there a fasting regimen that for everyone? Can any person find some type of fasting or time-restricted eating that will be appropriate for them?
I think the answer is yes, but as we know, it's working with individuals. So generally, when I'm bringing this idea to someone, I'm bringing it to them at a 12-hour time frame. Oftentimes, if there's any significant metabolic issues that are going on, I will start them off with using a fasting mimicking diet for 5 days to kind of jumpstart and get them into a good cleansing, a good metabolic reset that goes on, that then makes it easier for them to move into, starting at 12 hours per day. I'm like, look, 8 of the hours you're sleeping. And so do you need the popcorn before dinner, or do you need to have, the cream in your coffee in the morning, right? You can drink coffee black, you can drink tea, you can drink green tea, you can drink water, liquid. You're just not eating anything that's caloric in nature. There's a whole question about, well, what about these, ketogenic supports, that just have fat? Do they really count? And I don't think we know the answer to that. So I just err on the side of, well, I'm going to be clean about it. I'm not going to be adding stuff to, my morning coffee. And, if I don't like the taste of it, then I'll find a tea that works for me. Usually it's a green tea or matcha is my favorite. But, I do think that there's a way that everyone can benefit from this kind of thing, because that's how we as humans have been created over time.
Everyone who just learned they can have coffee and tea and still be fasting now, it seems so much more realistic. Well, Patrick, we have so appreciated hearing all of these clinical insights today. I think you've inspired us to keep our eye on the literature and see what emerges in terms of fasting and our gut microbial composition, our immune health, our brain health. So much to chew on. And I want to extend my gratitude for everything you've shared with us today.
Thank you, for asking me, and for the work that you're doing to bring these ideas out to our patients, our friends, our families, and to the greater public at large. Appreciate your work.
To join the conversation on this topic, visit IFM's pages on Facebook and Instagram. For more information about functional medicine, visit ifm.org.